Hey, morning everyone. This is John, and today we're going to talk about something sexy. We're going to talk about rendering. Stay tuned, this will get exciting. In visual effects, animation, gaming, rendering is that moment when you press the big button, send all your hard work off to computers to calculate, and hope that it all comes back on time. But it's not so simple. Every visual effects studio has had that moment where something has gone wrong. Maybe a new project has come in, schedules have changed, and suddenly there isn't the capacity required to be able to get that project done with the internal resources. So studios will surge to the cloud. But cloud rendering is something that makes people very nervous because it can cost a lot of money, especially at a premium at the last minute, and can really compromise your budgets. So while it's this insurance resource, it also can take a huge hit on your bottom line. Visual effects studios are nervous about using cloud resources because it's an unpredictable resource. It's really hard to know in advance what that's going to be, and as a result, they're reticent to use that. The problem is spreadsheets are currently the key thing that people use to be able to model out their forecasts. And really they're just a static single snapshot in time, a bunch of best guesses, and then really we're in a reactionary moment when things actually hit the fan. Today I'm going to show you how we are solving capacity, and specifically render capacity, with the software that we've been building. The thesis is you should be able to have multiple what-if scenarios all running in real time and be able to spot all these potential trends weeks, if not months in advance. So stay tuned, dive in, and I'm going to show you our latest and our greatest, and I look forward to your feedback. Here we go. All right, so let's dig in. This is a basic example. We have our render resources. We have two projects, Project A and Project B, that have render needs. We're running some calculations. Eventually we'll get into a scenario here where we talk about what happens if we pull some of our work up in the schedule, what happens if we push some of it later in the schedule to offset render needs. We're going to calculate some variance. What happens if we use 20% more than expected? What if we use 20% less? And what if we rent from the cloud, or we use rentals to be able to get this work done? We're going to run 18 different scenarios in this model, all in real time. Let's dig a little bit deeper in. Render resources. This is what do we got? So in here we have profiles for different types of CPUs, right? We have the number of processors that we actually have of each of those type, and we're generating what's called a normalized render unit. Think of it like bid days for doing work. This is sort of like bid days for doing rendering, all right? So we're able to generate with that what our render units needed are. But we get a little bit more fancy because we know that rendering is not a continuum, it varies over time. So Project A, for example, we say there's going to be 200,000 render units, and we have a distribution, how we expect to use those over the duration of the project. We do the same thing for Project B. Maybe this one has a temp delivery, so we can model that into our scenario here at the same time, save that curve, update it, and resimulate. So that gives us, once this is done, our render profile, right? So we're able to sit there and look at what's needed for Project A, what's needed for Project B, what the combined render units are required here inside of that one, and then we're also able to look at what our available render units are. So here you're already starting to see the problem. There's what we've got and then what we need to be able to get this project done. Okay? We also, on the fly here, can use our calculation event to calculate what our shortfall is going to be. So for example, here right now, this is our render shortfall, the number of units we're going to be short on. And in here, we also have our cloud cost. We put some fictional numbers in here. But off the bat, this particular project is going to cost $444,000 to be able to surge to the cloud to be able to get it done in time. Okay? Wow, that's going to be a problem. But that can actually vary. So let's look at our best case, worst case, and middle case scenario. So now I'm recalculating. Here I'm saying what happens if we go 20% over, what happens if we go 20% under. So now I have a range from $813,000 all the way down to $135,000 to be able to render this project in the cloud given our shortfalls. Great. So the first thing we might want to do is take a look at it, and do we really need to render at this particular sort of pace and overlap? So I'm going to lock this back in for simplicity's sake here right now, and instead I'm going to unlock this particular set of nodes. And I'm going to recalculate, and then I'm going to explain what we've done here. Everything is a curve, everything is timeline based on our software. So if I go back to our needed render units right now, and what the profile of our show looks like, what if we're able to take Project A and weight that earlier in the schedule? Or what if we're able to take Project A and weight that later in the schedule? Again, something's easier said than done, but we've got that in our model. What we're able to do is we're able to take that initial profile that you saw for Project A And we're able to multiply a second curve upon this one to sort of front load all of this work. Obviously, that would have overtime costs, other things associated with it, but being able to get more work done earlier in the schedule if possible. Or what if instead we actually push this? What if we try and delay project A deeper into the schedule there? So I can also multiply this curve to weight things towards the end of the schedule. And what do you get? You now get 3 different scenarios where we can see what happens when we pull things forward, pull things backwards, and now when we look at our render shortfall, we can sort of see 3 different scenarios here. And then the cloud rendering costs, accordingly, are also now more realistic. 188,000 all the way up to 539,000 if we're able to shift some of these things in the schedule. Lastly, we can talk about, is it possible to bring some rentals on board? So I can able to look at a scenario here where I say I want to add 4 more processors, a start date and an end date. Ultimately, you'd want to have a cost for renting those as well to bring those online. So now I've got 18 different scenarios. So if I turn all of these on and recalculate, now we're able to see all 18 scenarios, what our range of render costs could be from $28,000 up to $921,000, all months, if not weeks in advance. What you see here in red right now is something we'll be adding in. So it's also the ability to calculate and pull in from AWS or Google Cloud or whatever it is, your actual renders consumed to date. Just like bid days, we want to be able to take a look at what we said we were going to need and when we said we were going to be able to need it to be able to understand whether we've actually consumed those resources at that moment in time or not to rebalance and reproject the remainder of the schedule. Anyway, that's a quick version of things. Ultimately, the goal here is to be able to make some decisions, right? So maybe we do decide that we are going to push Project A a little later in the schedule. We are going to do rentals instead of cloud here. We're going to keep our 3 variances. We're going to rerun this model, and now we have a sense of what our costs are going to be, what our shortfall is going to be, and what our options are going to be able to deliver this project on time. Anyway, that's a quick sneak peek at what we're doing. If this is something that you or your facility is interested in, please reach out, and I'm happy to talk some more. Thanks.